Welcome back, team. Here is a video on one of the level 3-4 questions called About Bias. You'll find this in our recent week's task list or practice exercises, I labeled them as. And here's the solution video for it. Okay. So the problem stems from a high school creating a 15-member committee that handles decisions. The school-wide committee consists of 10 adults and 5 students. There's a principal named Principal Pfeiffer. They have been asked to select a special subcommittee of 6 people out of this group of 15. Students are furious because they just learned that the subcommittee consists entirely of adults. They feel that the principal stacked the subcommittee with adults and didn't consider any of the students. Principal Pfeiffer, however, claims the subcommittee was chosen randomly. The students have decided to present their case to the school board. So here we have a problem because students are in this committee with adults, and they feel like if there's a committee that was randomly made, that that students would be in this subcommittee. So here, before we even get to the first question, you can already tell that we're dealing with 15 members. So if this is a problem that has to deal with combinatorics and probability, it's nice for us to kind of identify the 15 member committee. Okay, so I'm going to write that over here. 15 member committee. I think that's how you spell committee. Yep. There's a 15-member committee, and within this committee, there are 10 adults and 5 students. Okay. Eventually, there's a subcommittee, a second group out of 6 people. So a 6-person subcommittee. Okay, I'm not doing any real math yet. I'm just kind of organizing my information. So we have 15 members. There's a 6-person subcommittee that's created, and out of this 6-person, it could be any combination or any groupings, I'm going to say, of these students. Okay. And then students are mad because the subcommittee that they made ended up being all adults. Exclamation point, because that's a problem. The students wanted to be in it. Okay. So now we have a little bit of something to work with. Let's see what we can do. So number 1 says, as a part of their presentation to the school board, they want to tell them that the probability of getting only adults, if the principal is selected, they wanted to show the probability of getting only adults if the principal selected 6 people at random. This probability we need to find and give our answer as a number and as an expression using the notation NPR or NCR appropriately. So once again, let's just talk about this notation. NPR is talking about a permutation, and NCR is talking about a combination. And the difference between the two, the difference between the two is that order matters. Okay, and we'll talk more, hopefully, about order matters in this problem, so that way you don't get yourself confused when you're taking a test. With a combination, order does not matter. Okay. So here we have a problem that's a little bit set up. So let's talk about our path to answer the question. Okay. So ultimately, for number 1, I'm putting this number 1 up here. We want to find the probability of a subcommittee that has only adults. So a 6-person committee, a 6-adult subcommittee. Okay, so we want to find a 6-adult subcommittee. Okay, well, the first thing we need to do in order to do this, in order to find some sort of probability, is how many possible committees are there? Actually, let me write this a little bit separate and a little bit bigger. Okay, I'm going to do this in green. Okay, in order to answer this question, we need to do a couple things. Number one, we need to see how many committees are there. Or 6-person committees can we make? Oh, let me zoom out a little bit. How many 6-person committees are actually possible using this 15 member? And then we want to see out of this, how many of them out of this, the overall number of 6-person committees that can be made, how many 6-person committees are only adults? Okay. And so here we need to kind of talk about what the deal is. And using these two pieces of information, you can determine the probability of selecting an all adult group. Okay, so let's break this up into chunks. Let's look at how many 6-person committees are possible. In order for us to do this, we need to determine whether or not the problem is a combination or a permutation. And let me go through what I'm thinking about in order to prove one or the other. Okay. So first and foremost, let's talk about permutation. If it is a permutation, do I need the people selected to be in order? In other words, do I need the 6 adults that I have chosen to be adult number 1, adult number 2, adult number 3, adult number 4? If the answer is no, which it is, I don't need them to be in order, then this would be a combination problem. Okay, so this is in fact a combination problem. Okay, we don't care about the order of the adults. We just want a combination of adults that are in the group to prove to the school board that they are biased. Maybe. We'll see. Okay. So since it is a combination, we actually don't need this section anymore on permutation. You don't even need to worry about permutations. Okay. So what I'm going to do here is I'm actually going to kind of zoom out and just go over here so that way we can look at a fresh problem. Okay. So if we're looking at a combination, we said that if we're going to be looking for the how many 6-person committees are possible, just in total, we're going to use every single person. So we have 15 people, and then our R is going to be 6. In other words, we're using NCR with this formula such that we have 15 people that we're choosing from, and we have 15, we're choosing 6 of them in order to be represented in a committee or a subcommittee. So in this problem, I'm going to use this equation, and I'm going to replace the R and the N's in the denominator as well. So I want to make sure that we keep those in line. We start plugging in our values. Then we can simplify a little bit. 15 factorial. Remember, the exclamation point is called a factorial. It's not that we're just excited for 15. It's a factorial. And then we can subtract these, so we get 9. And then now we can do an expansion of this factorial. When we expand, I'm going to put it in red here. We can expand it. Remember, we're expanding by multiplying. So we have 15, we start with the number 15, and we multiply it with every value that is below 15. And I'm going to have to write a little small here, so I apologize. 6, 5, 4, 3. Got to zoom out. Times 2 times 1. And then we're going to put whatever's in the denominator. So we have 6, 5, 4, 3, 2, 1. We're going to expand this 6. I'm going to put a set of parentheses around it so that way I know exactly what I'm looking at. Oops. Then I'm going to put another multiplication symbol. I really want to make sure that I keep it a little bit separate. And then I'm going to do the other one. Remember, you can't multiply these together. So here we can't multiply 6 times 9 together within the set of parentheses. It doesn't work that way. Okay, so here, since we can't do that, I'm just going to expand the 9 as well. And at this point, some of us in class have mentioned that you see a certain pattern or something going on. Here, since we're multiplying everything in the numerator and we're multiplying everything in the denominator, and there's no other operations that exist, we can actually take everything that is multiplied on the top that is similar to the bottom and just cancel them out. So the 1s, 2s, 3s, 4s, 5s, 6, 7, 8, 9, all of them would cancel each other out. Which means this factorial will actually simplify to only 15, 14, 13, 12, 11, 10, all divided by 6, 5, 4, 3, 2, 1. Okay, now there's a lot of different ways that you can also solve this bottom or this factorial, but what I like to do is I like to simplify it just a little bit more. Okay, and what I notice here is that if I keep the numerator the same, 15, 14, 13, 12, 11, 10, in the denominator, I like to think, hey, because these numbers are a little bit smaller, can I multiply any of them together to get any number that's in the numerator? The answer is yeah, I can. And in fact, I like to start with my bigger numbers and eliminate them first. So if I look at this 6 and this 2, and I'll multiply them together, I end up with a 12 in the denominator. Okay, cool. Well, 5, I can multiply with any of these, but 5 and 3, I would get 15. So 5 and 3, I would get 15. Times, and then 4 times 1 is just 4, so I can't really do anything there. And now I just created two numbers, the 15s and the 12s, so I can cancel even more. Okay, now if you don't want to do this step, or if you're kind of lost saying, Hernandez, I have no idea what you just did, it's a little bit confusing, then have no fear. You can just multiply the entire numerator and the entire denominator and then just divide them. Okay, but using this method, looking at the numbers that can multiply together to get you another number, that makes your math a little bit simpler for you to plug into the calculator to really make sure that you're not messing up any sort of multiplication or division as you continue through the problem solving process. So here, if I multiply the 14 and the 13, I'm going to get 182. Multiplied by 10 is going to be 1,820 divided by 4, which gives me an answer of 455 different 6-person committees. Okay, so we're going to use this to answer the problem. Now, this is part of the mathematical process that helps set up for us to calculate the probability. So here we're going to use this information of 455 different 6-person committees. And over here, I'm going to write that over here. 455 6-person committees. Possible 6-person committees, okay? Now, if I want to use this information, I need to remember our original question is that we're trying to find the probability of a 6-adult subcommittee. Okay, 6-adult subcommittee. Okay, so what we need to do is we need to figure out, hey, how many of these, I'm going to put this question here, how many of these, we can call them combinations now, are all adults? Okay, so we need to work through this and try and figure out, hey, how many of these 455 six-person committees are actually consisting of all adults? So it requires us to be a little bit clever in using our math to solve for something like this. And so if we look, what we need to do is actually solve the second question, how many six-person committees are only adults? And so in order to answer that, what I'm going to do is I'm actually going to scroll up. I'm going to rewrite, I'm going to actually do this. Boom, I'm going to keep just this information. And we want to know how many of these combinations are all adults. Well, let's answer this question. We have 10 adults, and we want to choose 6 of them. Doesn't matter which 6, for the subcommittee. So we're actually going to do the same problem solving as before, but this time we're going to still use NCR, but instead of 15, because we're going to get rid of all the students, we're going to only use 10 to figure out, hey, how many different ways can we organize those 10 different adults in a group of 6? Because remember, we want to know how many of these groups are actually going to be adults. Well, if there's only 10 adults to choose from, and we want 6 of them, and we want any combination, that will tell us, hey, how many of these are actually consisting of all adults? So here, let me just expand my factorial. And when I do so, I'm going to do the same type of trick, except I'm just going to take it a little bit easier on this one, so that way you can see what's going on. So I'm going to take 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And remember, we're multiplying here. We're not adding, subtracting, or anything else. And then this, oh, I didn't simplify that. 10 minus 6 is 4. We can expand. 6, 5, 4, 3, 2, 1, multiplied with 4, 3, 2, 1. And if you look, just like before, the 4's gone, 3's gone, 2's gone, 1's gone. We could simplify it out. And it will always be the case that you can reduce the last couple numbers as long as you expand it and see it. And so hopefully you can see the pattern as you continue. 4, 3, 2, 1. So here you can do what I did before, and then just find other numbers to actually reduce this by. However, if you didn't want to and you wanted to just multiply it all out, you can still do that. And so here I'm going to do it quickly. So 10 times 9 is 90, times 8 is 720, times 7 is 5,040, times 6 times 5 gives me 151,200, divided by 6 times 5 times 4 times 3 times 2 times 1 is 720. I think I did the math on the top wrong. Let me double check. Divided by 720. Actually, this gives me 210 different ways that we can organize number of 6-person groups with all adults. Okay, so let's kind of summarize what we did so far, because there's a lot of information. It looks very jumbled. We're trying to answer this one question. Find the probability of a 6-adult subcommittee. Okay, this is the question we're trying to answer. So let me rewrite it down here and kind of open it up so that way we can see what we need. So the main question is, what is the probability of an 6-person adult subcommittee. So if we're trying to find this probability of this adult subcommittee, we want to know the probability of, actually not the probability, we want to know the number of adult committees. Possible adult committees. And we want to just know also the total number of committees possible. So that way we can determine the probability of this. So remember, the probability tends to have a structure that looks like this, like a fraction, okay? So when we do this, we found that the total number of adult subcommittees possible are 210. So there's 210 ways, as we found here, that we can form an all-adult committee. And what we did earlier is we took every possible person in the committee, so there's 15 people, and we determined how many possible 6-person committees that we can make in total. So that number is 455. So this whole thing actually gives us the probability, I should have wrote it over here, the probability of a 6-person adult subcommittee. Okay. So then the probability becomes a little bit easy to look at because we get 210 divided by 455 equals 0.46. Or in other words, you can change this to a 46% chance of actually getting an all-adult subcommittee. And so when you look at this, we can actually count out whether or not this is a very probable chance. And actually, I think Hernandez made a really big mistake. Let's check this out. Oh, yep, made a mistake. The mistake is actually up here. Okay, so I'm looking at this problem. I'm trying to figure out, hey, 46% sounds a little bit high. It shouldn't be that. And it's because here is my mistake. Okay, so I took you through this problem solving process. Hopefully you fixed it. Mistake is right here. We forgot the 11. We forgot to put down the 11. And this is what I get for going quickly through the problem solving process. But this is important that we start thinking about, hey, what have we done? And does it make sense? And I'm looking at this, and if I have 10 adults and 15 members, I need to choose 6. I feel like picking all adults is a little bit more rare than 46%. I don't think 46% is actually correct. And in fact, it is incorrect. So the solution that I should have received is 5,005. Okay, 5,005. And let me double check that really quick. Make sure we get all of our work checked. 14, 13. 14 times 13 times 11 times 10 divided by, that's my answer. So here I get 20,020 divided by 4 is, yes, 5,005. So same process applies. It's just instead of the denominator being 455, I made a little mistake there. The denominator is actually going to be 5,005. So I'm going to just go like this. And this would give me just a slightly different answer. So if I take my calculator, I do 210 divided by 5,000, 210 divided by 5,005. Yes, this seems a little bit better. 0.041. So if I turn this into a percentage, I get 4.1% chance. Yes, that's a little bit more rare for us to get an all adults committee, which is appropriate. Why our students are upset? Because it's only a 4% chance. It's highly unlikely. Okay. So this would be my answer, and you can write this as there is a 4.1% chance of receiving an all adult subcommittee. Okay. And then for number two kind of asks you, is this stacked? Or essentially rigged? Do you believe it's rigged? And then you can give me your own interpretation of that and explain. I think, yeah, it's rigged. Highly unlikely. And seeing as though there's 5,005 possible groups and the principal is picking them, he says he picks them randomly, but maybe it's not random. Yes, there is a chance, but it's very, 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 very rare. So, with that said, this is how you kind of connect combinatorics and probability together to get something. It boils down to something very easy and trivial. You just need to make sure that you understand how to set up the numerator and denominator of this probability as you continue forward. Hopefully this helps, and I'll catch you in the next one.